Hey everyone, good morning, good afternoon. Today, we are going to talk about how to modernize your Apache Spark data processing pipelines. My name is Bhanu Prakash. I am a product manager in Snowflake and I work on Snowpark. With me, I have Brandon.
Hey everyone, I'm Brandon Carver, and I'm a product manager working with tools and applications here at Snowflake.
Awesome. So, we are going to talk about 5 different things as part of this session. We are going to talk about the challenges with the traditional data engineering pipelines. Then we'll introduce Snowpark as part of how to simplify your data transformation architecture and pipelines. And then we'll do a quick demo as well as comparison of code of Apache Spark with Snowpark in terms of the semantics and syntaxes. And then we'll go do a demo of the Snowpark migration accelerator, followed by end-to-end Python pipeline demo with Snowflake, including Snowpark. So let's jump into it. So you as a data scientist or data engineers or in data professionals, you have a choice of tools as well as programming languages that you are supposed to use as part of creating your data engineering pipelines. And then you have been asked by your organizations and teams to innovate and derive insights from the data faster than ever before. As a result of that, because your preferences may vary, some may use Python, some may use SQL, some may use Java, all of this adds to complexity of the end-to-end architecture. For example, like with traditional Spark, you may have to have different cluster types itself based on the programming languages. Or you have to think about resource sizing or plan for capacity and whatnot. Separately, because Spark itself is a in-memory technology, as in, for the most parts, you have to get the data to the compute, or even in case of pandas, if you're using, you have to get the data to the compute. What all of this results in is a loose security and governance model because data has to leave the boundary of the existing security perimeter. Not only that, now, because you have to have separate compute clusters, it also means that the data itself has to be duplicated in various places. So all of this results in pipeline failures, potential of missing SLAs, as well as an extra overhead, as well as cost for maintaining this complex architecture. To double click on that, let's take an example of what's the getting started experience with Apache Spark. So as I mentioned, if you start from compute itself, you have to think about capacity, you have to think about the VM queues, as well as what are the specific configurations of those VM queues. And guess what? You have to think about if you are if your solution runs on multiple clouds, these queues and sizes will differ across clouds as well. Let's go to the network security. Now, if you have to manage virtual networks, VPC and VNets, then you have to think about also the firewall rules. Think about maybe using a third-party firewall appliance and whatnot. From a disaster recovery perspective or HA, you have to think about how to set those up for all the entire pipeline. There isn't a single click experience. And then especially if you are multi-cloud, you have to now think about designing that solution that differs across different clouds. And then this is just the like compute storage and network part of it. Think about the actual Spark runtime, like the experience of just configuring and playing with the knobs can be overwhelming even for a simple data pipeline. Not just that, as I mentioned, that the data has to move to the compute, you have to start thinking about data security in terms of data ingress and egress. And then the TCO is not just going to be the cost for the managed proprietary Spark vendor, but you also have to think about TCO in terms of the virtual machines, the storage cost, the network cost, like all those costs add to your end-to-end TCO. And then if you run into issues, you have to think about, you have to talk to the vendor of the managed Spark provider, as well as you have to work with the cloud providers if there is an infrastructural issues. For example, you could be completely running out of capacity of a particular VM in a region, and then the burden is on you. All of this is just an extra hurdle that distracts you from focusing on the actual data pipeline. So how about a platform or a solution that takes care of all those complexity while having you just focus on the business problem or the creating of the or the data transformation? And this is what Snowpark is, which is offered as part of Snowflake, where it provides a code execution platform that allows you to run Python and other programming languages like Java, Scala, or even your customized runtime at scale next to your data using the underlying warehouse engine. So to double click on it, Snowpark comes up with data frame APIs or machine learning APIs. Now, if you think about data frame APIs, these are the same similar APIs that you would get as part of PySpark data frame APIs. So from a look and feel, it looks pretty much similar. So as a data engineer or a data scientist, your day-to-day life will not change in terms of just creating the pipeline. But then what it helps is when Snowpark was designed, it was designed with a mind to help organizations and teams to scale. And the way it achieves is by running those code, whether it's the data frame APIs or your own user-defined functions and procedures, right on the same warehouse. So the warehouse itself, what we do is we do not require you to create a separate compute. Rather, your code gets pushed down to the warehouse engine, and the warehouse, which has been solved all these problems of removing the complexity since the beginning, comes it for free for your data pipelines as well. And then with security and governance at top of it, you don't have to worry about all those extra security measures that you would have to otherwise worry in other managed Spark or even Spark in an IS fashion. And then from a scale perspective, because the warehouse scales on demand, depending on your data size or how much of data needs to be processed, the warehouse just scales on demand. So let's take a look at how the end-to-end overall data transformation pipeline looks like. On the ingestion part, we have got streaming auto ingest with Snowpipe streaming, where in a serverless manner, the data can be streamed and ingested. We also have got Kafka connectors. And then on the transformation side, while I talked about Snowpark, which allows you to run Python, Java, Scala, as well as Snowpark compute container services, we also have dynamic tables that allows you to, in a declarative manner, specify the target end table, and then we take care of the pipeline management and the additional complexity. So it helps you build a reliable ETL pipelines. And then on the delivery side, we have Streamlit that allows you to build visualizations, as well as you could build native applications on top of your data, or you could use Power BI or a visualization dashboard tool to connect to the data available in a gold format. Now, all of this comes with end-to-end DevOps experience, which I'll be talking about in a moment. And at the same time, whether your data is in Snowflake or whether the data is in open storage format like Iceberg, it all works end-to-end. In fact, Snowpark, since it went G8, we have had multiple customers migrated from their traditional data engineering pipelines to leverage the robustness scale as well as modernization capabilities available with Snowpark for their benefits. And the benefits speaks from the numbers. As you see, on an average, customers have seen 4.6x faster average performance over managed Spark, and 50% of the Snowflake customers are using Snowpark, and it has helped on an average to do cost savings as well as performance. In fact, Jim, who is the head of data engineering and ML from Hyperfinity, has a quote that says Snowparks enables us to accelerate development while reducing cost associated with data movement and running separate environments for Python and SQL, which they would not have to do with Snowpark. So let me hand it over to Brandon to talk about, give a demo as well as before and after Apache Spark journey. Brandon.
Thanks, Banu. That was a great overview on how you can simplify your life by using Snowpark, but how would you test it out? Can you move your existing pipelines from Spark over to Snowpark? Yes, you can. Snowflake has created the Snowpark Migration Accelerator. to help you understand what you're going to move from Spark to Snowpark, the code, and help you get there. The SMA is a local application that takes in files from a local directory and analyzes them. It's completely secure. No source systems are connected to or accessed by the tool, only code files and notebooks. Now, this is not a regex or a glorified find and replace tool. The SMA scans a code base. It creates a complete semantic model that represents the functionality in the code base. And then from this model, two main artifacts are generated. The first is a detailed report on all code elements in the code base, including readiness, compatibility scores, as well as the exact location of all references to the Spark API or any imported libraries or packages you may have. And the second is the output code designed to mirror the functionality of the original in Spark in Snowpark. So recall that this is an accelerator. The SMA does not convert 100% of code from the source to the target, but what can be functionally recreated is, and what cannot be is marked with comments in the output code that include error codes and supporting documentation. So let's see this in action real quick. In the interest of time, I'll be fast, but note that the SMA is freely available from Snowflake on the website by using this QR code. And you can also find your way to the same demo that I'm going to fly through right now. So let's jump in. So this is the SMA application. Like I said, it's a local application, and you can set up a run by filling out a few fields here. There is a source and a target directory that needs to be specified so that you can analyze the code that's available on your machine. This is the source directory I'm going to analyze. There's a series of Python files and some notebook files. You can kind of get an idea of what these look like by jumping into a code editor. This is the Python file, which is a basic operations on some data frames. And there's another one here that we can highlight that is a notebook file that is doing more basic operations on data frames. And you may be more familiar using a Jupyter notebook in a Jupyter environment. And this is the exact same code file that I'm going to run through the tool. So going back to the tool, I've already filled it out, so I'm going to go ahead and run the tool. The SMA is building that semantic model that I already mentioned, and note that it's not going to take a whole lot of time to run, about 15, 20 seconds. If you have an exceptionally large workload, it could take longer than that. But the assessment is going to be generated at the end of this, and it's going to give you a series of readiness and compatibility scores. These scores are designed to indicate how ready or compatible your code is with Snowflake or with Snowpark. There's also a series of reports that are going to get generated. You can view the reports here, and they kind of look like this. There's a summary of all the files that you have. You can pivot those out by file to see what percentage of this file is ready for conversion. You can look at each individual usage of the Spark API, every package that's imported. You can even look at other third-party libraries that may be an interest, such as pandas. And you can even review any inputs and outputs that you have in your code base to determine what data sources are being read from or written to. There's also a complete breakdown of all the issues that the tool generates, meaning you can find exactly what the tool couldn't convert very quickly. Back over to the tool, if I want to run into conversion mode, all I need to do is select an access code, which is automatically generated by the tool, and continue on to conversion mode. All that's going to happen differently now, the same semantic model is being built, but now we're going to get output code generated in an output directory. The summary information should be the same, unless you've made changes to your source code between running it, the assessment, and running the conversion. And the same reports are also going to be generated as well, so you can re-review those if you'd like. We strongly recommend you doing an assessment first and getting a good understanding of your workload before you run a conversion. And you can always reach out to us if you need additional assistance on that. You can view the output code by clicking on View Output, which should take you again to a local directory with the output code that we've seen here. And we can see a comparison on the source and target quickly if I jump into a code editor. So on the left, we have the source code that I showed earlier, and on the right, we have a converted output in Snowflake, or ready for Snowpark. There's some simple things that are converted, like import statements, where the tool can't convert something or it identifies something that maybe you should take a look at, or maybe there's a workaround for. you can see that an EWI or an error warning is inserted as a comment. If you use the SMA Assistant, which is a VS Code extension available from Snowflake, you can remove these or learn more by going straight to the documentation page. Now, the same conversion also happens on the notebooks that I showed earlier. So we can see some import references change, and we can see those same EWIs generated. And just as we were running that source notebook in a Jupyter environment, we can now run the output notebook in Snowflake by using Snowflake notebooks. So that is our very quick overview of migration using the Snowpark migration accelerator. I'm going to throw it back over to Banu, who's going to give us a little more in-depth overview of some of the things you can do in Snowpark.
Awesome. Thank you, Brandon. So now we'll talk about what are the latest and greatest updates to Snowpark, as well as how all of this fits end to end as part of Python pipelines to modernize your data pipeline. On the authoring itself, excited to share that Notebooks is available in public preview that allows you to write interactive code in a cell-based manner for both Python as well as SQL. And then on the transformation side, I'm excited to share that Snowpark Pandas has been GA, and this allows you to write same similar Pandas style code, but then the way it runs on Snowflake is with the same design principles I spoke earlier, which is the code is pushed down to the compute, to the data, and then Snowflake engine takes care of handling the complexity as well as the scale for running Pandas at scale. I'm also excited to share that external access, which was already available in GA, now comes up with outbound private link, which is going to be GA soon on Azure, as well as in public preview on AWS. We already had made dynamic file access as part of unstructured data processing available. I'm excited to share that file writes, which is a natural complement of file rates, is going to be available in public preview to help with all the unstructured data processing use cases. And then last but not the least, we have now made available Snowpark optimized warehouse with resource constraints. What this does mean is that you have the option to specify, uh, choose CPU architectures as x86 for your underlying warehouse, which would enable your packages with native code or your code with C++ dependency based on a particular CPU architecture to run natively on Snowflake, as well as artifact repository, which is going to be available soon, that allows you to connect to PyPy and get packages, Python packages directly from PyPy and use it as part of your UDFs or procedures. On the pipeline orchestration, we have got serverless task flex as well as serverless task for Python as well as Java available. This allows you to drastically reduce not just your cost, but also you don't have to care about specifying a warehouse, because we take care of the warehouse and right size it based on the job profile, thereby reducing the TCO. And on the DevOps side, we have got so many different things from Snowpark local testing to Snowflake CLI, Git integration, and whatnot. So let's take an end-to-end look of how this looks in a real demo. So as part of this demo, I'm going to play a role of a data engineer at a retail analytics company called ZK Company, where I'm going to show you a 360-degree overview of the analytics with Snowflake. So there are three key areas that we'll be focusing on. One is the user engagement, which allows to understand how customers interact with the product and services. The second is user feedback and experience, which is analyzing customer reviews and feedback to uncover common themes as well as sentiment analysis. And then the third is impact on sales to evaluate the direct correlation between customer feedback and sales performance. Now, this is how it all fits end to end. We have the product sales data available on a transactional database in Azure SQL. This needs to be ingested to Snowflake, and we are going to use Snowpark external access with private endpoint that allows the traffic to go over private link. Then we are going to ingest data from social media websites or platforms using public external access. And then finally, we are going to use Snowflake Cortex that allows to extract sentiment and issues from the review. Then we are going to join both those tables and then visualize the data using dashboard using Streamlit app built within Snowflake. And then we are going to do vector embeddings for the product sales and sentiment data to build a chatbot, RAG-based chat box. And then finally, to share the reports, we are going to use the newly capability in Snowpark called file writes that allows you to write the data to internal or external stage. So let's get into it. So as I said, the first step is the SQL where the data is available, where the data needs to be ingested from. So this is my SQL instance on Azure. And as you see here, from a networking perspective, the public access is disabled. So to give you a sense, I first ran ahead to this procedure to go ahead and fetch the data, thinking it's going to be on a public network. But it results in an error that says to connect to this server, use the private endpoint from inside your virtual network. So now we have to go ahead and set the outbound private connectivity. If you're already familiar with external access, there is literally no change in using private connectivity feature, except a couple that I want to highlight. One is provisioning of the endpoint itself, the private endpoint, which will be provisioned within Snowflake using this system function. And the second is as part of network rule, you have to create type as private host port. Now I've already set this up, and then to get a glimpse of what those private endpoints are provisioned, you can also run within the notebook to take a look at how many private endpoints are available within your account that you or other users may have provisioned based on your privileges assigned to your role. Now, let's go ahead and create this function that connects to the SQL server, and using this module PyTDS, it's going to fetch the data, and then I'm going to fetch that data and convert to a JSON string, and then I'm going to return the list of JSON string to the caller. So in this case, I'm calling this function connect underscore SQL server that I defined in the previous step by specifying all the authentication as well as the connection string. And so I'm going to run this function. As I am running this function, it's basically converting the list of JSON string to a pandas data frame. So you see here the category description, product ID, product model name, customers, as well as quantity is available to read. And this is all happening over a private network. Just to get you a sense, we have already enabled audit log that allows you to get the data of what the source or the destination, as well as the source IP and the sent or transferred bytes, received bytes are available. So you, from an audit perspective, can monitor this as well. Now I've already ingested the data from public social media sites where I can see the product tweet and post date. So this will allow me to do sentiment analysis on the tweets of the product. Now to do that, I'm going to use Snowflake Cortex engine. As part of that, I'm going to provide prompts as part of extraction instruction where I'm going to provide tweet and the output like as a category. So let's go ahead and then run this using those instructions. And as I run this, I use Llama model 2 as part of this Cortex API, which is Python based. And then let's go ahead and look at the result of the data frame where the information was extracted. So here I can see the product, and then the two columns you see here, issue and sentiment. So I already did the sentiment analysis of a tweet being positive or negative, and then categorize the issue. So the next step here is doing the join of the analyzed sentiment as well as the product sales data that I can use it to create a dashboard for stakeholders within the company. So I've already joined this, and then you can see this table with the joined information. And then let's go ahead and create visualizations using Streamlit. So I've already done this, and you can see the various dashboards like tweet sentiment distribution, total quantity of sales by category and sentiment, and whatnot. Now, the next step is to actually share these dashboards to various stakeholders within my company. And as a result of that, I'm going to use Snowflake File API that allows me to write files back to the stage for me to share. Now the files are generated. These are part of the query results and are available for 24 hours. So you want to copy these files to your persisted stage, like internal or external stage. So this is my function UDF underscore save underscore all chart as HTML. And as part of this, as you see here, I'm going to use Snowflake file dot open underscore new underscore result in write mode. And this is reading from the files that were previously saved as charts. So it's reading and then writing to a intermediary stage called result stage, and then you have to copy it to the final state. So this is where I'm doing the copy. I'm calling this function, and as you see here, as part of copy files, we are copying it into a result stage. This is my report stage where all the files are being copied. And then I'm invoking this function that I have used to call to open the file in the write mode, and all the files get copied there. So let's go ahead and run this function. But before that, I need to create the function. So let's go ahead and call this function. So the UDF underscore save underscore all chart HTML is created. And then I'll go ahead and call this function. And once this is called, now I want to show you how do you actually persist the files to the stage. So here I chose a particular chart that I want to save. And as you see here, I get the link of the file to download directly. And these would be saved on the stage. So let's go ahead and call this and then open. And then as you see here, I can see this chart readily available that I can share the URL of the file or share it locally within my organization. Now, the last step here is building the chatbot based experience. So as part of this, what I have done is you can choose the different models available. In this case, I am going to use Llama 2 model. And then I'm going to use a particular question and then go ahead and provide in the chat box experience and then ask the question. Now, behind the scenes, to explain, I have already done the vector embeddings of the data that I talked about in my initial walkthrough of the architecture. And then I'm running this. So it's going to give me the responses based on already the vector embeddings of the data available. So you see here, I asked this question, give me the recently posted negative reviews, and I can see the response. All right, I hope you got a chance to see this all end-to-end fitting together on how to transform your data engineering pipelines using Snowflake, and hope you enjoyed the session. Thank you for watching.
Yeah, and there's a lot of great resources to check out on converting your Spark pipelines over to Snowpark, so please check them out. Thanks.